Mahadevi, let me start. So this problem is from thermal physics. And the question is, we have a sample of vegetable oil initially in the liquid state, right? Vegetable oil, it is in liquid state, means a liquid phase. It is a liquid. Is placed inside a freezer that transfer thermal energy from the sample at a constant rate, right? So at a constant rate, you see, this is important. When we put the oil inside the refrigerator, so something happens, right? That we need to discuss. Here we have a graph. What happens when we put some stuff inside the freezer, inside the refrigerator, right? So what types of physics is there? What types of thermal physics is there? So it's not a difficult question. When we put some stuff inside the refrigerator, so stuff is taken from the room temperature, right? Yeah. And then it is kept into the refrigerator, which is at quite low temperature. So the stuff is at high temperature, the refrigerator is at low temperature. So when we put the stuff inside the refrigerator, so some heat transfer is there from higher temperature to lower temperature, from that stuff to the refrigerator, right? Means from the vegetable oil to the refrigerator, there is some heat transfer, right? From the oil, which was at the room temperature, now that is kept inside the refrigerator, so there is a heat transfer from the oil to the refrigerator, and from the refrigerator to the surrounding. So I can say there is a heat transfer from the oil to the surrounding, right? So how much heat transfer is there? So this is the graph we have. The temperature, which is in Kelvin, it is along the y-axis, and time, it is in minute along the x-axis. So we start from temperature 290, and finally the temperature is reduced to 250, right? So from 290 to 250. So you see, from 290 to 250. So what is happening? A sample of vegetable oil initially in the liquid state is placed in a freezer, transfer thermal energy from the samples at a constant rate. The graph shows how temperature T of the sample varies with time. So this is the graph, and we are given some more information, and we are given the following information. The following information we have the mass of the sample, right? Means mass of the vegetable oil 0.032 kg. Specific latent heat of fusion of the oil. Specific latent heat of fusion means the heat required to change solid into a liquid, right? The specific latent heat of fusion of the oil, right? If oil is just frozen, right? So how much heat energy is required to just transform that frozen oil into the liquid phase? So that specific latent heat of fusion is also given 130 kilojoule per kg, right? Kilojoule per kilogram. And rate of thermal energy transfer is equal to 15 watt. Rate of thermal energy transfer is equal to 15 watt. Then calculate the thermal energy transfer from the sample during first 30 seconds. First 30 seconds means up to here. This is the first 30 seconds, right? This is 30. So in the first 30 seconds means the temperature is reduced from 290 to 250, right? In the first 30 seconds, temperature is reduced from 290 Kelvin to 30. So we need to calculate how much heat is transferred from the oil to the refrigerator, because oil is at higher temperature. Yeah. It is taken from the surround, it is taken from the room temperature, then it is kept inside the refrigerator. So what will happen? The energy from the oil that will transfer to the refrigerator, and finally from the refrigerator to the surrounding. Yeah. Right? So how much heat energy is transferred from the oil to the refrigerator? We need to calculate that. Actually, when we are just keeping some stuff or some food or anything inside the refrigerator, so what happens? There is a transfer of heat energy from that stuff, from that food into the refrigerator, and then from the refrigerator to the surrounding, right? So now how much heat is transferred from the oil to the refrigerator? We need to calculate. So now very easy. So heat transferred from oil to refrigerator. So heat transferred. Okay. So during the first 30 seconds, means from time 0 to 30, not second, it's a minute. In 30 minutes, in half an hour, how much heat is, means refrigerator is on, the oil is kept there, and we are investigating within 30 minutes how much heat is transferred from the oil to the refrigerator. So time is 30 minutes. So which formula we will use? Heat transfer, that is Q, is equal to power
into time.
multiply time. Very easy formula, right? Power of the heater is
15 watts.
Sorry, power of the refrigerator is 15 watt, and time is equal to 30 minutes, right? So Q is equal to 15 watt multiply 30 minute, convert it into second. So this comes out to be equal to 227, 15 multiplied by 6, 90, 90 multiplied by 3. So 2700, and the heat transferred, it is in joule. So this much heat is transferred. So let me just show, right? This much heat is transferred. Q is equal to 27. This is 100, or this is
27,000.
27,000, right? So 27,000 joule of heat is transferred from the oil to the refrigerator, and from the refrigerator instantly to the surrounding.
Yeah.
Right? So finally, this is going to the surrounding also. So this is the question is calculate the thermal energy transfer from the sample during first 30 minutes. So the statement can be in another way also. Calculate the thermal energy transfer from the oil to refrigerator.
Yeah.
Alright, or they can ask calculate the thermal energy transfer from the oil to the surrounding.
Yeah.
Right, same thing, same formula. So heat transferred from the oil to the refrigerator or oil to surrounding. Same formula will be used. So Q is equal to power into time. Power is 15 watt and time is in minute. We have to change minute into seconds so that we can get the energy into joule. Right? Now let us go to the second part. Okay. Oil in its liquid phase. Right? So we have the clue here. We have a liquid phase. State an appropriate unit for your answer. Estimate the specific heat capacity. Right? So why we are using the specific heat capacity? Why specific heat capacity term is here? What is the meaning of specific heat here? Right? So what is happening? Specific heat means we are changing the temperature. When we are changing the temperature, then we use the term specific heat. Right? The temperature can change from higher to lower or from lower to higher. So when there is a change in temperature from T1 to T2, then we use a term that is called specific heat capacity. So specific heat capacity. But when temperature is constant, means T1 is equal to T2, temperature remains constant during any process, Then we use the concept of latent heat. Latent heat. But in our question, estimate the specific heat capacity of the oil in its liquid phase, state and appropriate unit for your answer. So the formula, you will use the formula for the specific heat. So heat transferred from oil, that is equal to mc delta T, and heat transferred is Q, so Q is equal to mc T2 minus T1. Delta T is the difference in the temperature, because temperature is changing, right, from T1 to T2. Okay. So now we need to calculate C. What is the specific heat? This is the Avya, this is the specific heat. C is the specific heat. So we need to calculate C. So C, that will be equal to Q divided by M T2 minus T1. T2 minus T1. What is Q? Already calculated. 27,000.
Yeah.
Right? So Q is equal to 27000 joule. Mass is given. How much mass is there? So what is
0.32.
0.32 kg.
Yes.
0.32 kg. And T2 minus T1. T2 minus T1 means final temperature was 290
Yeah.
Kelvin, and then it reduced to the 250 Kelvin. Right? So 290 minus 250?
Yes.
40 Kelvin. 40 Kelvin. So this is 40 Kelvin. Okay. The mass is in kilogram, right?
Yes.
Okay, it's okay. Mass is in kilogram. So just do the calculation, James.
Okay.
So find C.
Yeah.
This 1 0 is cancelled. Right? Tell me the final answer.
Yeah. The answer is 2,109.37.
3,000.
No, 2,109, sir. 2,109.
9. 20,
Yeah.
2109.
0.375.
0.37. Only up to 2
Decimal place.
decimal places.
Yeah.
And this is in joule. The unit is joule, kg,
K.
and Kelvin.
Yeah.
Right? So this is the specific heat of this liquid, which is kept inside the refrigerator, and finally the temperature is reduced from 290 Kelvin to 250 Kelvin.
Yeah.
Right? So you see, the 290 Kelvin to 250 Kelvin, time is 30 minutes. Right? Time is 30 minutes. Okay? So let us see the another part.
Mister?
Yeah, Mahadevi. Okay. So this is the conceptual part now, right? The numerical part is done. Now this is a conceptual part.
Yes.
And I already told you that conceptual part is hard to explain. Mathematical part, numerical part, that is formula based, you can do easily. But when you are asked to explain something, means you need to explain the concept behind something, then that is a really hard part. So now we are at part B, which is a conceptual part. The sample begins to freeze from 290 to 250. So it begins to freeze. So sample begins to freeze because temperature is changing from 290 Kelvin to 250 Kelvin. Right? So temperature is lowering, means the liquid is turning into the solid.
Yes.
The oil is turning into the ice. So oil to ice. This process is going on. Oil to ice. Sample begins to freeze during the thermal energy transfer when energy Q is transferred. Q is equal to 27000 joule to refrigerator. When this much of energy is transferred to the refrigerator, then the oil just changes into the liquid. Right? Okay? So explain in terms of molecular model of matter. Molecular model of matter means we will consider that the oil is made up of molecules, right? So what is the molecular model of oil? Oil is made up of molecules.
Yes.
So we will consider the molecules of the oil. So why the temperature of the sample remains constant during freezing? So if you see the graph from after 30 minutes, the temperature remains same, 250 K.
Yeah.
It's a flat line parallel to the time axis. So why after 30 minutes means 30 minutes, then after 40 minutes, after 50 minutes? Because the refrigerator is on, right?
Yes.
So refrigerator is on, the oil is inside the refrigerator. So till 30 minutes, there is a heat transfer of 27,000 joule, right, within 30 minutes. And after 30 minutes, why the temperature remains 250 K? Why that is not changing? Why the temperature is not changing? Means now the temperature remains constant, that remains 250 Kelvin for all the time, for 30 minutes, right, then for 40 minutes, and then for 50 minutes. For all the time, why the temperature is fixed? So now this is a conceptual question in terms of molecular theory of matter. We have to explain this. So actually what is happening, if we see the molecules of a liquid. So if I imagine the molecules of the liquids, they are like this. They have a well-defined separation between them,
Yeah.
right? So this is a well-defined separation between them, right? When the oil was at 290, so when the oil was at 290 Kelvin. As the temperature reduces, so what will happen? They will try to freeze.
Yeah.
So the molecule, they will try to go close and close to each other, because when liquid turns into solids, the density increases. It means all the molecules, they need to go close and close to each other,
Yeah.
right? They need to
Get
freeze.
closer.
So in that case, what is happening? This separation between them is decreasing, right? So let me take this separation between them at 290 is R, right? R. The separation is R. So when, due to the temperature, due to the fall in the temperature, because temperature falls, so the temperature try to freeze them. So the temperature try to reduce R. So when R reduces, so what happens with the potential energy of the molecules? So in terms of potential energy, I will give my explanation. So potential energy of molecules, if you want to explain in terms of molecules, so you can say potential energy of molecules, or if you want to explain in terms of atoms, right? So you can say potential energy of the atoms. So potential energy, that is equal to, right, which formula we will use, right? Which formula we will use? We will use some constant K, right? And the charge on these molecules, Q, divided by R. This is the formula you have to keep in mind. This is the formula for potential energy, right? So we can write the potential energy of molecules. V is equal to some constant K, Q is the charge, and R is the separation. So you see, R is reducing.
Yeah.
R is reducing. So when R is decreasing, then the potential energy that has to increase. The potential energy that has to increase.
Yeah.
But potential energy is increasing, right?
Mhm.
So it means the kinetic energy that should decrease,
Yeah.
right?
Yeah.
The kinetic energy that should decrease. But the kinetic energy that will not decrease, this kinetic energy will not change. So what will happen? As per the science, if potential energy is increasing, then kinetic energy should reduce. But here, there is no change in kinetic energy, because if there is a change in kinetic energy, there is a change in temperature. But because there is no change in temperature, the fixed state line.
Also, then there's no change in kinetic.
So, because T is constant, since T
Oh, yeah.
is constant, so we will say kinetic energy cannot change. So actually, cannot change. So if kinetic energy is not changing because of the constant temperature, so what is happening? What is happening? It means the increase in potential energy, that will release the energy. Right? That will release the energy. Q is equal to 27000 joule. Right? Understanding my point? So, when temperature is constant, kinetic energy cannot change. So it means this increase in potential energy, that will produce the energy, means that will release the energy. So this will release the energy. Now this is a type of exothermic reaction happening in the refrigerator. When we put the oil, so that is an exothermic reaction. So release the energy. How much energy is released? Q is equal to 27000 Kelvin. So this is exothermic reaction happening with the oil inside the refrigerator. So in terms of molecular model of metal, why the temperature of the sample remains constant? So because the potential energy that increases when the molecules they come closer to each other, but because energy is coming out, energy is going to the surrounding. So it means when this potential energy that is changed into the energy, right? Potential energy that just releases the energy, right? So it means from from this sample of mass m is equal to 0.31 kg, right? In 30 minutes, in time t is equal to 30 minutes, how much energy is gone to the surrounding? This much of energy. So this, understanding my point? So the mass is equal to 0.3 kg within a time of 30 minutes, this much energy is right there. So after just transferring this energy, means this energy is produced at the cost of this, right? Because when the temperature is reducing from 290 to 250, so the molecules they are going close. So till after 30 minutes, if still the refrigerator is working, so nothing will happen because already now they are at the bond length. So finally, when it is a solid, so molecules they are at the bond length, right? When they are at the bond length, so they have a certain value of potential energy, right? So at bond length, right? So V, that becomes V fixed. This is fixed, right? Means when bond is created, when the oil turns into the ice, means there is a bonding, there is a bond length, the gap is reduced till the bond length. The value of bond length is different for different fluids, for different liquids. So for this oil, if the bond length is achieved, it means the potential energy is fixed. So after that, when this is fixed, right, now everything will be stable. Now if refrigerator will not do anything with that. Why? Because when the liquid that attains that temperature, 0 degrees C, right? So now the refrigerator and the stuff, they are at the same temperature. So there is no exchange of heat. So after that, the Q will become equal to 0. Understanding my point? When the oil attains 0 degree, right? So after that, because the two things, the stuff and oil and the refrigerator, they are the same temperature. So now there is no release of heat. Okay, so now you can explain in your own words also how this whole process is going on. This is a very microscopic observation about this topic. Okay, that's all.